monomial factors of polynomials. Here's the deal, guys. We are going to be starting to have, instead of a monomial as the numerator that we divide by a monomial, we are going to have a polynomial as the numerator. So the difference between this and what we've been doing is that because this numerator is a polynomial, in this case a binomial, it means there's addition and subtraction. So the first thing to know is you cannot cancel things, numbers, terms. Things is not a very good math word, but I think you know what I mean. You cannot cancel things when there is addition or subtraction. Right? I abbreviated there. You could write the words if it will help. You cannot cancel things when there is addition or subtraction. Here we've got an addition, a plus sign. With the binomial, we could end up with a trinomial in the numerator. We cannot start to cancel this 5. However, there is something you can do. The idea here is that everything here is being divided by 5. So the first way I'm going to break it down is to just show both of these numerators are being divided by 5. Everything in the numerator is being divided by this factor. This is one of the factors. Our answer is going to be the other factor. That's what we just reviewed from Friday's homework. I can separate it into separate pieces. If we look at each piece separately, everything in the numerator, again, is being divided by this denominator. If I look at each piece separately, is there any addition or subtraction here? Not in this piece, so in this piece I can now cancel. 5 and 5 both divide by 5, or you can think that they cancel out, leaving 1m. And then I keep the plus, and then if I look at this piece separately, 35 over 5, well, there's no addition or subtraction in that, so now I can cancel that piece. 35 divided by 5 is 7, or divide by 5, divide by 5, 7 over 1 is just 7. So here's the important part. Although you cannot cancel things where there's addition and subtraction just like this, the idea is that once we break them into separate pieces, well then they're just monomials. Then there's no addition or subtraction within this term or this division problem, and so then I can't go back to canceling. Let me show you one more that way, and then I'll show you a shortcut you can take. Let's do one more that way. 26 uv minus 39v all divided by the factor of 13v. By the way, this denominator that they give you is the factor, the first factor, right? Just like we were doing before. And yes, in Friday's work, they showed this in parentheses and you found the other one. Now the difference is, again, we've got a binomial. So to start, the way I want you to do the first couple problems is the way I'm showing them here, where we show that we are breaking it apart into the separate pieces of the numerator. Each term becomes its own fraction, and each term gets divided by that same denominator factor. Then if we look at each piece on its own, well, now there's no addition or subtraction, and I can cancel within that fraction. And then I go to the second one. Okay, no addition or subtraction, I can cancel in there. So 26 and 13 both divide by 13. It leaves 1 and 2. What else? If I'm just looking at this first fraction, so I'm ignoring the rest, so I can cancel because there's no more addition subtraction showing. What else can I simplify here? Vincent? Good. I can get rid of 1v from the numerator and 1 from the denominator, which means they cancel out. So what's left here? I have 2 times u over 1. 2u over 1 is just 2u. You should not have fractions left over. You should end up with whole numbers. Okay, 39 and 13 also divide by 13. That leaves 1 and 3. V and V, again, just like the first one, they're both going to cancel out. So I have a minus 3 over 1, just 3. Okay, now, I've been showing it. I've been showing it where you break them apart into separate pieces. I'm going to do one more that way, and then I'll show you how you can make it into a shortcut. This one, 3x to the 4th minus 9x cubed y plus 6 x squared y squared. Now, in order to save some time with your writing, I'm going to show you on this one. It is written the same way with a division bar all the way across and one denominator. Rather than us writing that and then having to rewrite it, let's just go ahead and show it breaking it apart. Negative 3x squared is the denominator. So rather than writing it down, I'll show you the way it is in your book, right here. Here it is. They have it first shown just as a whole fraction with one denominator. So when you see that, if you want to just immediately write it into your homework where you break it into the parts, you can do that. You don't have to write it one way first and then rewrite the whole thing. Now we're going to take each part separately, each fraction, and simplify it. And again, when I do it that way, there's no more addition or subtraction. It's just a monomial term, a monomial, and so on. So that now we can cancel. 3 divided by negative 3, what am I left with? 3 divided by negative 3, Luke? Negative 1. X to the 4th divided by x squared. How does that simplify? Anybody? Pammy? Okay, good. X squared. Because you can either think of it as the exponent rule says when you divide the same base, you subtract the exponents. 4 minus 2 is 2. Or remember, you can think of it in terms of canceling. I could get rid of 2 from the denominator, which means I can also get rid of 2 from the numerator, but since there were 4, there's still x squared left. Now, I have minus 1. You can just simplify that to minus x squared with my invisible 1. Let's do the next piece. Now be careful here, there was a minus in the problem, but my denominator is negative. So a negative divided by a negative makes a positive. 9 divided by 3 makes 3. What's going to happen with the x's? X cubed and x squared. Either we subtract the exponents or we cancel out. How many x's are left? Leanna?
1.
Yeah, I could get rid of 2 from the denominator, which means I can get rid of 2 from the numerator. But since there was x cubed in the numerator, I'm left with 1x. Or again, when you divide the same base, you subtract 3 minus 2 for the exponents. What about the y? What's going to happen to this y right here? Roland? It just stays there. There's no y's in the denominator to simplify it out. Good. Finally, I've got a positive or a plus 6 divided by negative 3. Positive divided by a negative makes a negative or a minus. 6 divided by 3 is 2. What's going to happen with my x squareds in this problem? Diego?
Yeah, cancel out.
Good. I get rid of 2 and 2, and it turns out they're all gone. And just like in the previous one, the y doesn't change. Now, for that first term, you could take out the 1 and write negative x squared. That's how I'll have it. But it's not wrong to have the 1. Okay, let's do one more. And now I will try to show you a little shortcut. However, if you tend to make small detailed mistakes, just the tiny details, then you may not want to take the shortcut. X cubed y minus 4x plus 6y. Again, your book is going to show it all being divided by 1 denominator. We have been breaking it apart into the separate parts. If you think you can keep track of what you're doing without writing it with an xy, xy, and xy under each part, you can try that. It's a little tricky. You've got to have neat writing. You've got to pay attention to what you're doing. But technically, all we're doing is we're dividing each one of these by xy. So if you think you can do that mentally without making mistakes, I'll show you an example. We don't have to necessarily write it if we can do it mentally. I'm going to take this first term and divide it by xy. X cubed divided by x. What do I get? Jaden? Okay, good. X squared and y divided by y, they would both cancel out. One from the numerator, one from the denominator. So I'm left with x squared. Now, again, you can just try to visualize it, right? We could cover up the other parts and try to visualize. Now, I don't have a denominator, a number in my denominator, so what's going to happen with that negative 4? It stays the same, right? I can't simplify it. X and x, well, I can get rid of 1 and 1, so they cancel out. Now, where's that leftover y? Oh, wait, you know what? Did I write this? Oh, I did write it correctly. Never mind. If I get rid of x and x, I can't cancel out the y. Everybody agree with me there? Okay, where's that y going to be when I write it down? CJ? Yeah, it's in the denominator. So make sure that you keep it in the denominator, right? If that's where the extra one is, that's where it stays. So just be careful that it stays in the denominator. Last piece. Now again, if I just cover it up, I can see what I'm doing. Or if you can just visualize it. The 6, well, there's no, again, no denominator. What am I going to be able to cancel on this? Jaden?
The y.
Yeah, the y and the y would cancel. So this one still has an x left in the denominator. Now this answer seems a little more complicated with the fraction, with those variables in there. But you don't have to do anything with it. You just leave it like that. Now, 8th grade, listen for a second. I was telling you about the schedule, but I just realized that normally in the past I've broken this into 2 separate lessons because this actually has 2 different kind of things going on. So I'm going to stop here. We're actually going to be finishing this lesson tomorrow. So that means your quiz wouldn't be until Wednesday of next week. But either way, it would still come before tutoring. So just make sure that you're asking for help. Okay, so we are going to stop there. I'm going to ask you to do page 196. This is written exercises. Numbers 2 through 20, evens. Be careful on these. They are written with the denominator just shown once. You can either try to do it mentally, or you can try to rewrite, 8th grade, you can rewrite them with the denominator under each fraction so that you can cross it out, or you can do it the way we did on this last problem and try to cancel things mentally. Be careful if you do it this last way.